Hi everyone. Today we are going to study an important topic in soil mechanics. It's known as a settlement of soil. Settlement is one of the most critical check in foundation design because even if a soil is safe against shear failure, excessive settlement can still cause a serious damage to the structure. Okay. Here these are the content we will discuss one by one: settlement, objectives of settlement, types of settlement, and then comparison between uniform and differential settlement, causes of settlement, followed by caudal provision and settlement analysis, concluded with merits of induced settlement techniques. The first one is settlement. Settlement occur when soil is subjected to stress due to structural loading. This stress causes deformation within the soil stockland due to rolling, sliding, slipping and crushing at a particular contact periods. The cumulative vertical deformation over a depth of influence is known as a settlement. Here a simple example is when a building is constructed on a clayey soil, the soil particle rearrange and compress over time, which leading to the permanent downward movement of the structure. Okay. Next one is a objective. Here objective is to compute settlement beneath foundation and predict differential settlement. This help engineering design and foundation that are safe and functional throughout their service life. Settlement analysis also help in choosing suitable foundation type. Right? Here these are all the types of settlement. Total settlement consists of three categories. First one is a immediate settlement, primary settlement and secondary settlement. Each type occur due to different mechanism and different time interval. The first thing is immediate settlement occurs instantly upon application of load due to elastic deformation of soil particle without any change in moisture content. It is also predominant in sandy soil and unsaturated clay. One example is when a temporary load such as construction equipment is placed on a sandy soil, the ground settles immediately and stabilizes quickly. Okay. After that, primary consolidation settlement. This one occur due to expulsion of pore water from saturated fine grained soil under sustained loading. This process is time dependent and controlled by soil permeability. Here simple example is in a clayey soil, a building may continue settlement for several years as water slowly drain out of soil pores. Okay. Followed by next one is a secondary settlement, which is also creep settlement. Okay. Secondary settlement occur after primary consolidation is completed. It is caused by slow plastic deformation of soil under constant effective stress and is significant in organic soil. Here example is structures built on beat soil may continue settling even decades after construction. Here this one is a example diagram of settlement. Here first one is a immediate settlement and below portion is consolidation settlement. Here various type of settlement images are there. Okay, first one is no crack and dipped is mostly without cracks and with cracks. Okay, here generally before compression voids portion is very high, but in after compression voids portion is reduced. So remaining reduced voids portion is called del H. Okay. The next thing is uniform and differential settlement. Differentiate. Uniform settlement occur when the entire structure settle equally and is usually not harmful. But in differential settlement occur when different part of settle unequally, causing crack and or tilting will happen. Example, you know that landing of Tower of Pisa a classic example, okay, of differential settlement due to uneven of soil condition beneath of foundation will happen. Okay. The next thing is causes of settlement. Various categories are there. Causes. Okay, here excessive structural loads exceeding the soil bearing capacity. Okay, after that settlement may occur due to weak or poorly compacted soil, change in groundwater level, nearby excavation, vibration. Okay, various causes are there for settlement of building. In general, small example is lowering of groundwater table near a building can increase effective stress in a clay, leading to additional settlement will happen. Okay. Next thing is the codal provision. Here, according to National Building Code of India SP 7 1970, the differential settlement shall be kept within the limit to which the superstructure can accommodate itself. Okay, the total settlement shall be so restricted only. After that, these limits depend on soil type and foundation system. Okay, here the condition is generally satisfied if the total settlement is limited to 50 mm. Okay, and also this condition is generally satisfied if the total settlement is limited to 75 mm also consider. The next one is a permissible settlement in the codal provision. Same Indian Standard Code IS 1904 1986 third revision suggests that the most of the concrete structure, the angular distortion to be within the 11500 normally and 1,11,000, where it's desired to avoid any kind of damage. This value will be suggested. Here this one is a simple example for permissible settlement in the codal provision mentioned. Here various types of footing are there: isolated footing and also sandy and hard clay involved in the isolated foundation. After that, isolated foundation for reinforced concrete structure, for steel concrete structure, and raft foundation for steel structure, and then followed by raft for reinforced concrete structure. Okay, various type of foundation with structures in are mentioned. Here settlement are all values are mentioned in mm. Maximum settlement in the isolated foundation for the steel structure is in a sandy hard clay 50 maximum mm. Plastic clay for steel rain structure is 50 mm, and then differential value is 0.0033 length. Okay, for both sandy and hard clay and plastic clay, and also angular 1 divided by 300 for both sandy and hard clay. Okay, similarly isolated foundation for reinforced concrete structure 50-75 maximum settlement value given, and then 0.0015 length differential settlement given, and angular value 1 divided by 666 value are even in the as per the code. Okay, similarly raft foundation for reinforced concrete structure, okay, 7500 for a sandy hard clay and plastic clay. Okay, similarly angular 1000 sorry 1 divided by 500 for both sandy and plastic clay. Okay, in the settlement analysis, totally in geotechnical engineers perform settlement analysis during the design phase to predict the magnitude and rate of settlement and ensure it's remain within the tolerable limits. Okay, the settlement analysis is carried out using various parameters: modulus of elasticity, compression index, coefficient of consolidation, and initial void ratio. Modulus of elasticity is mentioned in E, compression index EC, coefficient of consolidation CV, and initial void ratio EO. Okay. Finally, merits of induced settlement techniques. Here various benefits are there: to optimization of foundation type by using the settlement techniques, to predictability and risk mitigation to be reduced. Okay, cost and efficiency of the building will be reduced, reducing the material waste. That mean understanding the settlement limit mean allow the use of lightweight concrete or ground improvement instead of total soil replacement, reducing excavation, material cost and carbon emissions. Okay, and also to flexible design adaptation will be improved, pre-construction stabilization involved, preloading, okay, and a expedited consolidation will happen. Various several advantages are there by inducing the settlement technique. Okay, after that, to conclude, the settlement is a serviceability issue that governs the long-term performance of structure. Understanding the settlement behavior allows the engineer to design the foundation that are safe, economical, and durable. I think hope this session has given you a clear understanding of the settlement of soil. Thank you. Thank you for watching.